Alright, so in this video we're going to talk about acid nomenclature, or in other words, how to name acids. Okay, now this is kind of a big hint that you know you're dealing with an acid when you look at a chemical formula, is that hydrogen typically comes first. Alright, so for example, this is an acid. Alright, um, this is not an acid. Alright, other examples, here's an acid. This is an acid. All right, and so hopefully you see that a pattern is that your hydrogens typically come first, and that's how you know that we're dealing with an acid. Now, there's two types of acids really. There is what we call an oxyacid, okay, and a non-oxyacid. Now, it's pretty simple. An oxyacid, all right, is basically an acid that contains an oxygen, all right, while a non-oxyacid is an acid that does not have oxygen contained in it, all right, and that's just kind of like the big naming things or naming schemes when it comes to naming acids. All right, and so the first ones I'm going to talk about is actually the non-oxyacids. It's just simpler to name, and then we'll get to the oxyacids portion. All right, so non-oxyacids. How do we name them? All right, so it's pretty simple. I mean, all you really need is the prefix hydro and then the suffix acid. So let's talk about what I mean by that. So let's just say we have this acid here, HCl. Now, as I said, with all non-oxyacids, you use the prefix hydro, and then you'll use the suffix ic acid. Okay? So let's look at HCl for example. So HCl consists of hydrogen and chlorine. And just like we said, all acids pretty much going to have this hydrogen up in front. So that's expected. And so to name it, I will name this compound hydro. Once again, here's the prefix. We'll use the root of the second element. So this is chlor from chlorine. All right. And then ic acid. So hydrochloric acid. All right. So let's look at another example. We have, let's say, HBr. Okay. So HBr consists of hydrogen and bromine. All right. And so that means the name of this compound is hydrobromine. So we use the brome part because that's the root of the second element. So bromic acid. So hydrobromic acid. All right. Let's look at another example. Let's say, oh, look, H3P. Okay. So it consists of hydrogen and the element phosphorus. All right. And so in this case, we have hydro, because that's your prefix that you always use. We'll use the root of phosphorus, which typically is phos. So phosphoric, all right, and that's the suffix ic acid. So hydrophosphoric acid. And that's just pretty simply as that, all right? And so when you're looking at non-oxyacids, it's just you use the prefix hydro and the suffix ic acid. All right, so hydroic acid. All right, and you always use the suffix of the second element. Okay. Now, when we're going backwards, so for example, we have hydroiodic acid. All right. Remember, all acids consist of. We know that we have hydrogen. Okay. We have hydrogen, and then also we have If you look at iotic, all right, the root is iode, and the only element that has that root is iodine. Okay, and so if you're writing the chemical formula for this, you just always have to think about your charges. All right, hydrogen is always a +1, iodine is always a -1, so this is a 1-to-1 ratio, so simply be HI. Okay, let's look at another example of writing the chemical formulas for acids. So let's say we're dealing with, oh, here's a good one, hydrosulfuric acid. Okay, so with hydrosulfuric acid, all right, we're dealing with, we always know that we always have hydrogen, okay, and then we look at the root for this sulf, so sulfur, S. You have to consider the charges for each of them. We know hydrogen is always a +1 charge, sulfur is always a -2 charge. All right, and so when we combine those two, we need two H's, one S. So hydrosulfuric acid is H2S. Okay, and it's kind of like a little hint or cheat sheet. You will always need as many H's as the charge of their nonmetal. So like in this case, since the charge of sulfur is 2, you need 2 H's. The previous example, since the charge of the charge of iodine was 1, you need 1 hydrogen. Kind of give you another example, one more in this case. So let's just say we have hydronitric acid. Okay, so we have hydrogen, nitric, nit. All right, so we're talking about nitrogen. Look at the charges. Well, we know hydrogen is always +1. You look in the periodic table, you see the charge of nitrogen is -3. All right, and so how many hydrogens do we know we're going to need? Well, hint, we'll need 3 of them. Okay, so it's H3N, so hydronitric acid. So these are for your non-oxy acids. So now let's talk about your oxy acids. All right. So your oxyacids, they typically come in a more of a polyatomic form. So you have hydrogen with a polyatomic. So like for example, H2SO4. All right, SO4 is a polyatomic that contains an oxygen, or HNO2. All right, here's your polyatomic that contains an oxygen. Here's a polyatomic that contains an oxygen, so oxyacids. Or H3PO4. PO4 is a polyatomic that has an oxygen. Okay, so these are your oxyacids. So now let's just talk about the general rules of naming oxyacids. All right, so it's basically like this. If the polyatomic, right, and it's all about the polyatomic. So if the polyatomic name or suffix, all right, more specifically, ends with 8, okay, so like nitrate, chlorate, sulfate, phosphate. If it ends with 8, you will change it to ic acid, all right, if it's an acid, okay? If the polyatomic ends with an ite, you will change it to us acid, okay? So let me tell you exactly, let's go to a couple examples so you know exactly where I'm coming from with this. So like, let's say, for example, we have H2SO4, okay? So here is an acid, an oxyacid, that contains a polyatomic. The polyatomic has an oxygen. All right, so what you want to do is look up SO4. Figure out what's the name of this. So you realize SO4 is sulfate. That's the name of this polyatomic. Now, it's in this acid form because it's bonded to 2 hydrogens, so we need to name it as an acid. Well, since sulfate ends with 8, what we're going to do, we're going to change the 8 to ic acid. All right, and so in this case, H2SO4, the name for this is sulfuric acid. Okay, now a couple of things I want you to notice here. One thing that we never do with oxyacids, you'll never use the prefix hydro. All right, is you will never see hydro um, in the oxyacids. All right, so if you see sulfuric acid, all right, then you know that you're dealing with a oxyacid or you're using a polyatomic that has an oxygen in it. Okay, so let's just go through a couple of more examples. All right, so let's talk about HNO2. Okay, so if you notice, we got a polyatomic. The polyatomic contains an oxygen, so it's an oxyacid. All right, so we got to go with the oxyacid rules. So um, we first need to figure out what's the name of NO2. Well, the name of NO2 in this case, the polyatomic NO2, is nitrite. Okay, and so nitrite, since it's an acid, we need to name it as acid form. We know that we have to change the ite, all right, to us acid. So we have nitrous acid, and so that's the name of this acid compound. Okay, let's just go through a couple more examples. All right, so let's just say we have H3PO4. Okay, so forgot the name of this polyatomic, which has an oxygen, so we're going to use the oxyacid naming. So the name of this polyatomic is phosphate. All right, so because it ends with 8, we'll change this to ic acid. All right, and so what we're going to have at the end is H3PO4. The name of this is phosphuric acid. All right, so that's how you basically name oxyacids. All right, and if you were to go backwards, it's the same basic idea. And so let's just say we have um, ooh, nitric acid. So how do we know it's an oxyacid? Well, one, there's no hydro in front of it, so that means that the root of this has oxygen in it. Okay, so how can you figure out what's the polyatomic? So just kind of look at this. Remember, the whole idea is 8, ic, ite, us, right? So if it has an ic, it came from an 8. It has an us, it came from an ite. So this is nitric acid. That means the polyatomic was nitrate. All right. And so if you look at the polyatomic for nitrate, it's NO3. All right. And now we need to make sure we add the H's because it's an acid, nitric acid. That means it has hydrogens to it. All right. And so figure out what's the charge of this. We know the charge of nitrate is -1. Hydrogen is always a +1. So when you combine those together, it's a 1-to-1 ratio. HNO3 is the answer. Okay. Let's look at another example. Let's say we have sulfuric acid. All right. 8 ic ite us. All right. So this is us. It came from ite. So we know that it comes from sulfite. All right. What's the chemical formula for sulfite? It's SO3. It has a -2 charge. All right. All acids always contain hydrogens. Hydrogen is a +1 charge. And just like we spoke about earlier about non-oxy acids, how do you know how many oxygens you need? Well, that's the charge of your anion in this case. So we need 2 of them. So the answer to this is H2SO3. All right, so this is how you name acids overall.